So let's read this question. So the question says that consider the following solutions, that is 0.1 molality C6H5NH3 plus Cl minus, 0.1 molality KCl, 0.1 molality glucose, 0.1 molality Na2C2O4, 10H2O. So these are the solutions, and we have to find out the correct option. For there are four options, and we have to find out the correct option based on these solutions. So let's solve this question. So first we have the solution with highest boiling point is 0.1 molality Na2C2O4 10H2. So first we will write all the ions that is given in the question. 0.1 molality C6H5 NH3 plus Cl minus, 0.1 molality KCl, 0.1 molality Na2C2O4, 10H2O. So now we'll find out the boiling point. So we know that boiling point of solution is boiling point of pure solvent plus I into Kb into molality. So this is the formula. So now if we put the values, then we can easily find out which has more boiling point or which has highest boiling point or lowest boiling point. So this is constant because it will remain same always. So molality is in our three solution. Molality is same in each case, so it will remain constant. Kb is ebullioscopic constant. It will also remain same. Only it varies according to Ventov factor, that is I. So more the value of I, this part increases. If I value is the highest, then this part value is also highest. That means the boiling point of solution will be highest. So it only depends upon Ventov factor. More the Ventov factor, more the boiling point of solution. So in first case, that is C6H5 NH3 plus Cl minus, when it will dissociate, it forms C6H5 NH3 plus Cl minus. That means number of dissociated ion is 2. And if we find out the value of I, so we know that the value of I is 1 plus, here we'll write the formula of I, that is 1 plus n minus 1 into alpha. So here n is 2 minus 1, as alpha is not given, so we will take the value of alpha as 1. So it will become 2. So the Ventov factor value for C6H5NH3 plus Cl minus is 2. Now we'll find out for KCl. So when KCl dissociate it from K plus Cl minus, and number of dissociated ion is 2. As number of dissociated ion is 2, so I value will remain same, that is 2. So in this case also I value 2. In case of HCl, KCl also I value is 2. Now Na2C2O4 10H2O. Na2C2O4 10H2O. So when it will dissociate, it form 2Na plus C2O4 2 minus plus 10H2O. So here number of dissociated ion is 3, but it is neutral. So number of dissociated ion is 2 plus 1, that is 3. That means here I value will be 1 plus 3 minus 1 into alpha value 1. So it will become 3. So in these three solution, among these three solution, Ventov factor is more in case of Na2C2O4 10H2. That means if we'll compare these three solution, then boiling point or highest boiling point will be for Na2C2O4 10H2 because it has highest Ventov factor, that is 3. So as the Ventov factor is high, so solution high boiling point of solution will also be highest. So option A is correct because the solution with highest boiling point, it has highest boiling point. highest boiling point. The solution with highest boiling point is 0.1 molality Na2C2O for 10H2O. So this is correct. Now option B. So option B is the solution with highest freezing point is 0.1 molality glucose. So another thing is glucose is there also 0.1 molality. Sorry, glucose. So 0.1 molality in case of glucose also. As glucose is a non-electrolyte, so I value is 1 for glucose, and if we'll find out the so I value is 1, so it is lowest, because if we'll compare this 4 solution, then I value will be highest for Na2C2O for 10H2O. So now the freezing point. So freezing point, we will see freezing point. So freezing point of solution is freezing point of pure solvent minus I into Kf cryoscopic constant into molality. So this remain constant, this remains constant, this remains constant. Now it only depends upon the Vento factor. So if this part will be highest, then if this part will increase, then freezing point of solution will decrease, because we subtract it from pure solvent, freezing point of pure solvent. So for freezing point of solution to be highest, this part should be lowest. So I value should be lowest. That means if we'll find out the highest freezing point solution, then it should have the Vento factor less or lowest. So if we'll see these 4 solution, so glucose has the lowest Vento factor. That means it has highest freezing point. So 0.1 molality glucose, as glucose has a Vento factor 1 or lowest Vento factor, so it has highest freezing point. Highest freezing point. That means the solution with highest freezing point is 0.1 molality glucose. So this is also correct. Now option C. So option C is 0.1 molality C6H5NH3Cl and 0.1 molality NaCl will have same osmotic pressure. So we know that osmotic pressure is pi equals to ICRT. Pi equals to I, that is Vector factor, into CRT. So C is concentration, R is the universal gas constant, T is temperature. That means these three are remain constant. It only varies according to Vector factor. So before we find out the value of I in both cases, in case of C6H5NH3Cl and in case of NaCl or KCl. So in both cases I value remains same. As the I value remains same in both cases, like I if we take this as I1 and this I2, so I1 equals to I2, that means pi1 is equals to pi2, or they have same osmotic pressure, as they have same Vento factor, that means, and it only varies according to Vento factor, so as they have same Vento factor, so they have same osmotic pressure. So option C is correct. Now D. So D is 0.1 molality glucose solution will have the lowest osmotic pressure. Is because osmotic pressure is I into CRT, and it only varies according to this part, like Vento factor. Who has the lowest Vento factor? That solution has the lowest osmotic pressure also. As glucose has the lowest Vento factor, so glucose has 0.1 molality glucose has lowest osmotic pressure. Lowest osmotic pressure. Generally, all depends upon or varies according to Vento factor. If we know the relation between the a boiling point, freezing point, osmotic pressure with Venter factor, and if we'll find out the all the Venter factor of all the solutions, then we can easily figure out, or you can easily solve these questions. So generally we have to remember this formula, that is I equals to 1 plus n minus 1 into alpha, and all the formula of uh, boiling point of solution, freezing point of solution, how they are related, osmotic pressure. So this is the solution. Hope you understand it well. Best of luck.